for coming. We're going to get started since we have a full menu of speakers and not too much time. And I'm going to give you all a chance to hear from them. So thanks for coming. I'm very happy to present this sort of quick-fire round of fabrication and other oriented speakers today that we've invited here to GSAPP to talk about the practices in fabricating objects and in the subject of fabrication practice. Like I said, I'm going to be as quick as possible so I can see the floor. But I'm Josh Jordan. I teach tech and visual studies courses here, as many of you may have noticed, and then I also manage the administration and the operation of the Fabrication Lab. That's a sort of general description without a title, because I feel like my title keeps changing as the sort of arc of the goals of the school change from semester to semester, and the shop itself changes, which is happening right now, which is great. So today, I'm going to do a simultaneous tie-in with the speakers of this talk, as sort of makers that are sort of very big in scope and also very local in New York City, and a quick hijacking of them talking to announce again the renovations that are happening to the so-called makerspace, as yet unpermanently named everything space that's opening. And I say opening because this is what it looked like yesterday. Opening in the coming weeks here. The culmination of a couple years of planning and wrangling through different administrations in the university. Sort of intense sport of getting it done, and it's just about done. So the space is a step in the ongoing plan to expand and fortify the facilities of the school. But do it with a considered and ambitious remaking of the somewhat limited physical actual size of the spaces we have, like everybody knows. But it's also to give a stage to some of the most interesting things that are already happening here in the realm of making things, as well as a sort of an aspirational move to imagine what else could be made here. And what new scope of research the Fabrication Lab could embody or house there in terms of physical room that we can give people and sort of ideological room that it gives people at the school. So on the very direct level, we're, as a lot of people know, we're going to be consolidating the digital fabrication stuff that's in OPS with the other fabrication, some digital, some non-quasi-digital things that we have going on in the shop today. Putting them in one space, we're going to be staffing it a bit differently, so you may see some new people, some familiar people, and providing gradually a bit more democratized access to the tools. That means more sort of opportunities for self-directed and crew-directed training, and sort of more direct access in a DIY fashion to some of the machines. That's going to happen sort of progressively, so stay tuned for that. So on an expanded level, we're getting some new equipment, we're getting some big and some little CNC machines with different functions. A flexible 24/7 staging area that is going to be simultaneously a complete mess and very clean, I'm sure, to accommodate research in other things like VR, AR, robotics, more. And above that, it's brand new and it's sparkling clean, and they've engineered the HVAC in that place so that the air is going to be fresher than Central Park. So that's what I'm looking the most forward to. I've seen it, the ducks are huge. So this is what we're opening over the next couple weeks, and this is why I say opening. So that's the hijacking, my plugging the new space. So the tie into the people who have been gracious enough to join us today is the question of what the purpose of the space is in the context of the mission of a school like GSAPP and what it is now and what it's going to be. And what it does is continue to connect your experience, the student experience, to a culture of making things that can expand beyond the school. So in the conversations that we have here, I mean, the conversations between me and the people who work in the shop and use the shop and other students and faculty, the question comes up all the time. Nothing prompts us sort of what is happening next, what are we going to do next, what should we get next, what next question, than the imperative to fill a laboratory with cutting-edge technology, which is what we're trying to do. But also at the same time, nothing seems to be changing or outdated as quickly as emerging technologies. So it's a pressure-filled question and ambition that moves faster than shifts in architectural educational styles. But what we kept coming back to is the fact that whatever we do here at Columbia, it should be done with the intention of fomenting GSAPP and the Fab Lab as a sort of a node in an atlas of, oh, there it is, as a node in the atlas of fabrication in New York as a locality. That our facilities, our programming, our operational styles, our attitude, whatever, should be as opportunistic as possible about trying to tie us technically and educationally into things that are being made out in the city that are usually within a subway reach. So, and that's in different modes and methods of practice here in New York. And that we could and should operate like we imagine a studio would, in addition to being sort of a workshop and a physical wood shop. So, and because it's a compounding set of factors here, you probably all know, being in the city, being uptown, I think it's like literally close to the cloisters, the most cloistered part of the city. Being an architecture student and the habitual rhythms of sort of locking yourself in studio and intense focus, it's sometimes hard to see the actual outdoors for Central Park, fresh air, let alone another borough of the city to go find interesting things being done. And so you add that to New York's identity as a global center and hub for material things such as, for material things as much as for ideas. And so we see design ideas and initiatives quickly landing in the venues of international competitions, in publications. We see people's work that we know in biennials and biennials. Startups that bounce back and forth between here and New York, between here and Silicon Valley. So it's easy to forget that the means of production are often local and necessarily local. And anybody who's been in the shop knows that a really great idea that you have for studio often hits the reality of trying to push your way through Chinatown to get to that one place that sells blue foam, that's thick enough for how you want it. Suddenly 2 days are gone, you're trying to figure out how you're either going to put it on the subway or like if there's an Uber that's big enough to bring this thing back to the shop. So there's a very local reality to the things that we aspire to in the shop. So learning to be an entry in the geography of the city, I think, is important. The geography of innovative makers, and it really means understanding the city in those very, call them gritty terms, of finding your way to where to get things. And also understanding and knowing and familiarizing yourself with the network of collaborators or potential collaborators that there are, and they're doing really amazing things right here. So today's speakers, 5 of them, I think have all figured this out to pretty great results, whether in their ambitions and achievements as industrial makers, or as design partners with industry, the ways they maintain collaborations through teaching or research with design institutions, as much as the way that they bring academic world of design into contact with professional practice. And they all have this sort of common premise of evolving design thinking through making things, but are all uniquely broad in scope. And maybe most importantly, I think they each represent a sort of expanded story of one's sort of design intelligence and motivations in school, as a student here, continued into life and practice. So let me introduce them all very briefly, and then as the individuals come up, I'll sort of interlude and give a more proper introduction. But first, today is Wes Rosen from Situ Studio. It's a very multidisciplinary design institution based in Brooklyn. There we have Wendy Falk, an architect, organizer, and professor in New York. She runs the practice We Designs, has a connection to GSAPP through New Ink, and she teaches at Parsons. We have Ariel Asseline-Lichten, architect, proprietor of Slash Projects, another multidisciplinary practice in Brooklyn, a division of which is Slash Objects, which you'll hear something about. We have Ryan Johns, a fellow GSAPPer who bounces between here and Princeton. Ryan is a prof here and the founder of Grayshed, which is a digital fabrication, robotics, interactivity research and design studio. And finally, we have Madison Maxey, founder of Lumia, designer, inventor. She's both a local and international expert now in the emerging field of smart textiles, and a prolific producer of things digital, analog, wearable. So first, let me introduce Wes and Situ. So Situ is a multitude of practices in one organization. It's an architectural practice in the sense of a local design studio and architecture. It's one of the most robust fabrication production shops out there. And it's also a dedicated research institution that is engaging in questions of social and political research. So it's new technologies for hyper-customized space planning, for creative industries, digital forensics, conflicts in the Middle East. And Wes has been a New Yorker for a while, beginning at Cooper and running Situ since 2005, I think. So welcome, Wes.
Okay. Thanks, Josh. So let's talk about making. In thinking about how Situ began and sort of how we sort of arrived at what we're doing today, I wanted to start with this image, which is a scene that you should all be familiar with. Your standard architecture studio. Bits of masking tape, crumpled trace, laptop precariously close to the edge of the desk, lacy chipboard. This is the type of drawing studio and model making shop that my partners and I all enjoyed sort of thinking about architecture. This is a shop where you have drill presses, translucent welding curtain, shear, and this is where students are learning about perforations, folding, detailing, the material properties of such a wide range of materials that is really critical to the way that we start engaging the world as architects. This is where we're getting splinters, nicked knuckles, shaping raw materials to become something that has scale and meaning. School is a place for active experimentation, a complex situation that you navigate, actively questioning how you hack and modify the tools of architecture. Making is the mandate of architecture school. When my business partners and I graduated, we wanted to continue working in the ways that we enjoyed while we were students. We wanted to continue testing ideas somewhere between the drawing studio and a shop, between the digital and physical. We wanted to continue testing the tools of architecture, questioning the role of the architect in the practice of architecture. When you're in school working with the tools that you're going to have available to you in the shop that Josh is setting up, it's going to be easy to make. It's going to come naturally and organically. But what do you do when you graduate? There are a lot of offices out there that might have a small model shop, but more often than not, the opportunities are going to be staring at a computer, developing things digitally. So my partners and I set out to sort of try a different approach. We named this project Situ, and a month after graduating, we formed an LLC. This was in 2005, about 12 years ago now. And the company name Situ means the place or the site of something and its immediate surroundings. A situation is a set of circumstances in which one finds oneself or a state of affairs. To a similar image to what Josh just showed. So we're in the Brooklyn Navy Yard. We have our fabrication shop and office in close proximity to each other. We're also close to a lot of our clients, and our clients enjoy coming over to see how things are being made, quickly getting updates as we're moving from design through fabrication. The Navy Yard is a vibrant community. A lot of progressive manufacturing is happening there, a lot of CNC-equipped fabrication shops, a mix of various types of designers from textile to fashion to industrial design. Film studios, there's a rooftop farm, robotics labs there. It's also just great to be in this industrial landscape around all these historic buildings. Here, looking at a dry dock, this is a constant source of inspiration, certainly for us and our staff, but also for our clients. Our studio or office is, fairly standard. Open office, rows of desks, pin-up walls, conference rooms, material library. But what's unique about this office is the proximity to a fabrication shop. And that's certainly on everyone's mind as they're doing their drawing and we're talking to our clients. Our fabrication shop is in a building that was built over 100 years ago. It was originally a locomotive repair shop, so they would bring trains into this building to do repairs. There used to be some large pits in the ground where they could access the bottom of trains. We're one of the only standalone shops. There are a lot of massive buildings with wood shops right next to metal shops and various things, but it's nice to have our own building, our own space. It's 10,000 square foot space, tall. We have about 40 feet up to the rafters. It's like a 1-minute fly-through of the shop. So we're at the southern end of the Brooklyn Navy Yard near Dumbo. Went into one of our loading docks. Working with a lot of different materials. So at this end of the shop is where we do all of our woodworking. Standard woodworking tools, going over to our 5-axis CNC router. We have one of the largest thermoformers on the East Coast, a vacuum former and oven designed for working with corium materials. Going through the assembly area and then over into our metalworking area. So trying to get as much as we can out of a 10,000 square foot space, a lot of flexibility. Okay, so as Josh mentioned, Situ has 3 primary components, and I'll quickly sort of run through those and then show how they kind of come together. So Situ Studio, most of our design work is within sort of public space or public domain, working mostly with cultural institutions. The projects range from a system for installing solar panels on flat-top buildings, to working with the Brooklyn Museum on redesigning the entrance. With each of the design projects, what is built or imagined has been shaped by the unique problem set of each project and not by any stylistic agenda. A couple of our larger projects here. This is basically a makerspace. It's one of the largest in the United States. This is out at the New York Hall of Science. A space that is designed for mostly children to learn about science through making. So you have 5 workshop spaces that are all designed for different scales of making. We recently worked with Google on designing a 40,000 square foot office space. This is for Google's Creative Lab, which is a set of makers. They do everything from video production to prototyping different Google products. They work in teams that transform week to week, so we needed to build in a lot of flexibility in the space. Different types of meeting spaces, including little meeting pods. Components like this were designed and built by us. Right now we're working with the Jet Propulsion Laboratory in Pasadena to create a pavilion for them, taking a study of clouds and turning that into an architectural installation on their campus, which has about 8,000 engineers and scientists. Situ Research. So this is a division where we're working with architectural tools outside of making buildings, right? So working with Rhino, Grasshopper, all the tools that architects are working with on a daily basis, working with scientists or human rights groups. Doing essentially what is forensics. So we're an extension of the forensics architecture project, essentially reconstructing scenes, creating diagrams and animations that help lawyers make cases in court, but also talk about this work with the media. And then fabrication. So wide range of projects, different materials, a digital fabrication shop, so combining what we can do with CNC technology with old-fashioned craftsmanship. So here's a look at that 5-axis CNC router again, milling a piece for Neri Oxman. And then with these tools, we also have a team of about 20 amazing craftsmen who are able to take complex assemblies and do a high level of finish. A lot of lobby features, a lot of interiors here in the city. This is a stack laminated bamboo lobby wall that we did with KPF. Pleated marble wall for an office building in Midtown. A little standalone yoga pavilion for a house in New Jersey, working with CDR Studio. The geometry is based on a butterfly wing, so folding a wing into a box. Another look at that Neri Oxman piece. And then recently we worked with LTL on the School of Journalism auditorium, so creating the ceiling feature. You have these coffers made out of Ezo board, which is a recycled plastic felt material. If you haven't seen this, check it out, it's right next door. Oh, sorry. So 3 distinct divisions, and it's difficult to sort of define how they're distinct actually internally. But woven together is something like this. Just to quickly kind of zoom in on a project that is a design build project that I think is a good sort of reference for how these things all work together. This is a project that we did for a building that just went up in Dumbo at the north end of Brooklyn Bridge Park. The developers for this building, Alloy, came to us to create these sculptural panels that wrap around the structural core of the building, starting at 17 feet at the sidewalk and then extending into the lobby and becoming a feature wall. We were asked to develop the design right when the American Folk Art Museum was being torn down. We were all excited about that and wanted to sort of create an ode to this project. We couldn't work with metal, too expensive, but we could do something similar, possibly with concrete. So working with Alloy, went through a number of material studies looking at different types of aggregate that we could use in concrete, elements that could shift in the casting process, so ball bearings under a sheet of latex. We ended up arriving at this solution where we work with beeswax and salt, so essentially painting with wax into the molds and then melting the wax away afterwards to create texture. Taking this through fabrication, we set up a space in the Brooklyn Navy Yard specifically for concrete casting. So here you can see the wax in the molds, bringing in the concrete, which had a lot of black pigment in it, and then created a custom oven so that we could extract the wax after the panels had cured. And it tilts at one end so that as the wax is melting, it drips vertically down the face of the concrete and stains these vertical drips in the panels to accentuate the verticality. So here, the project completed, 17-foot panels at the sidewalk and extending into the lobby. And here's a little video that ties all that together. Crumpled brown paper was put on top of the casting tables to create a little bit of undulation, and then we pulled a sheet of acetate over the crumpled paper. Here, bringing in the hot wax, dropping some little beads of wax in, additionally to create little dimples in the panels. The panels are 1 inch in thickness. There's a lot of acrylic and loose fiberglass in the panels to give it strength, but also some flexibility. They can flex 16 inches over 17 feet. Okay, that's what I have.
So, thanks, Wes. Totally awesome, and more to it every time I see it. So next, Wendy, another multitudinous designer, architect, assistant professor at Parsons, practitioner in the Bowery through her work with We Designs. She's doing some of the most interesting board questions about fabrication practice and human experience and the interactions of them. Everything we look at, intersections between analog, digital, virtual, actual. So her work is a really great demonstration of digital fabrication expertise, I think, as much as it's concerned with the meaning behind it. So it's really good to have her here. In addition, her research, which has been supported by a lot of a diverse and pretty incredible list of academic partner institutions, looks at intersections between digital fabrication and ethics and law. So even more growing scope. Talking about the future of digital things where copyright and intellectual property, even ideas of ownership and authorship are changing and becoming more interesting probably. So Wendy, welcome.
Hi everyone, as I undress. And I first want to apologize to my colleagues that presented earlier, and I literally was Brennan. I was teaching a digital class, actually on copyright law. I'm doing kind of fun pro bono class at the Harvard Law School this semester. So I always start a lot of my lectures with this quote. A lot of it is because I know that without entering, none of our work and probably your work would be essentially available to be used. And I think this quote comes into play more and more kind of relevant to what we're doing, considering that there's a lot of discussion amongst human intelligence within computers and intelligence within humans using computers. So my presentation is quite heavy in a sense that a lot of the slides are also coming into play with a lot of my own research and how we're working within the practice and also the larger discussions of what we do and what I kind of see maybe the future of how design fabrication in the space in New York City could be a subject of context and contention. So this is our office space. Actually, one of our research assistants is here in GSAPP, Andre. He helps out quite extensively, and because of the partnership with New Ink, which is incubator with the new museum, we have been generously supported with the 4th floor space, which is about 4,000 square feet of space, and this is just a corner of it. And Ultimaker has been very generous in giving us a lot of the 3D printing support. This is one project we're working on. A lot of what my research is currently and moving forward with what our practice does is to kind of synchronize the ideas of how business, technology, and also people come into play. So this is a borrowed but like reinterpreted diagram from Yield & Co., more on the marketing and advertising side, but I think the way we interpret it is how do you add an experience of innovation and process of innovation within the marketplace. This is very, very early on white paper that I did for Acadia quite a few years ago, and I think it still is relevant onto how our practice works and how I teach. So a lot of it is on the ideas of physical output. There's many means and ways of doing so. However, I think as we are looking through the past 3 decades to maybe even like how 3D printing is in place, interactive fabrication and digital fabrication is hand in hand to the similar physical output, but then there is a kind of a sense of craft that also comes into play. I understand we have 15 minutes, so I'm not going to like go on my usual spiel. If the next slide will load, you will probably see a video that is put together with a few of my colleagues that we did for mostly South by Southwest, and these are kind of the ladies that I kind of feel is part of who I represent and what I work with. Nook is probably, some of you guys probably know, she does a lot of wearables, she's an engineer. Very fun stuff. I mean, like maybe the first beer/wearable machine that was at CES last year. Bana is also a trained architect, and she does a lot of sensorial experiences, but in particular, her focus is on fashion, and this is probably like pretty well covered on like New York Times, Women's Wear Daily, and all this other stuff, so it has sensorial experiences, and it kind of reacts to it, right? So this is where the whole intelligence of computational and how do we play with materiality start to integrate within the discussion. And then it kind of transitions into my colleague Tiffany's work, and a lot of her work is she's a performance artist. So she didn't directly model and design the piece, but she interacts with it and wears it as a performative aspect of the piece. So this was designed with in collaboration with Yannick Kitanen, who started Freedom of Creation and then sold his company to 3D Systems, and subsequently was a creative director there also, and shares an office with Will. Great friends, all these people, and just doing really amazing things. And then it kind of transitions to what I do, which is more on the built space and experiential side. So for us, a lot of the discussion on making, and it comes into play with this current topic, is what is making and how do we make? Do we look at the kind of design processes? Are there concept ideation? How much of it is actually getting your hands dirty? To what I go into the discussion of where Parsons is at right now is looking at kind of traditional means of making, which we do have steelworking, woodworking, and everything else. And we just introduced a 7,500 square foot, $40 million project by Luca and Rice. Designed, I'll show you later on the project of what Parsons is actually moving forward with the Making Center. And then to all of you who are classically known as architects, we understand as what Herzog as looking at iterations and prototyping. So this is me like down in the Autodesk Pier 9 workshop, and then going through that process of iteration all the way through kind of manufacturing. What do we do with manufacturing tools, and how does manufacturing start coming intertwined with the discussion that we are as designers, creatives, and or makers. So Jacob, I see, fresh face. So colleague Jacob was at Pier 9, so he knows these tooling very well. And I think what I really enjoyed about the water jet is that because probably I've never in my life had the access to it, and it's probably one of the most industrious and fun, like 3.5, 5 axes machine that I got to play with and prototype with. But a lot of this actually started maybe 7 years ago when I really just got really obsessed with 3D printers. So I had this like state-of-the-art spreadsheet that started maybe 7 years ago on looking at the current field of 3D printing and how it's engaged on the discussion of intellectual property. A lot of it was dealing with how do you allow access to individuals that might not have access to machinery. So you got the Autodesk version, and you get like anything from like a $15 to $0 machine that you could 3D print yourself with like a rip wrap, all the way to a 500K machine that's as big as this version. And then how does robotics come into, I mean, again, this is like a very synchronized like Pachikuchas presentation. I'm not going into like my usual spiel. I could go life on end on this. And it's on like the ideas of what are robotics and how do we actually work with robotics, and how does robotics actually start the larger discussion of automation and the future of work. And again, I'm really skimming through this. And then it kind of hopped into a lot of the kind of ideas where because of automation, because of manufacturing, and because of discussions of the rapid prototyping and file sharing that we're currently having in the age of digital property and online file distribution, it really came to the core when I talked to Patrick Schumacher, who I think most of you know is the now leading Zaha's practice, is where does copycat architecture come in, duplicature, and how do we start addressing the issues of ethical use of digital files? And then this is a great example of how Zaha's project at Hyundai was competing with the Tongcheng project that was also in line of speeding to get it built. So there were a lot of kind of intellectual property, I would say, derivatives, and then there was an ongoing settlement and lawsuit. But then what happens to your files and your work when you're actually openly distributing this amongst your peers, your faculty, and also, I think more importantly, what happens when you're actually sharing this with manufacturers and you're not manufacturing the piece yourself? Where it goes into a larger ethical discussion of 3D printing and future use of technology. And these are a few case studies I got sneaked into my dissertation at Harvard was what happens when you democratize 3D printing, what are the uses of it, how does bioprinting start being part of the discussion. Colleague David Rui, he's now the chair of SciArc's graduate program, looks a lot actually into the artful play of bioprinting, skins, and how does that start appropriating use of human genes and or animal and or different types of biological printing use, all the way to one of the projects that Autodesk has been really pushing forward is the Amber open source 3D printer, probably considered as one of the first open source market ready. I would say market ready in a very kind of conservative way because $3,000 isn't really considered as market ready for like everyone. But I would say it's market ready in the sense that you are enabling more than kind of industry to be using it. All the way to kind of the movement of the maker movement, right? And then there's that discussion of who is a maker, what does a maker actually do, and what did the magazine and proliferation of making actually increase into itself as a fair and as a larger kind of open market discussion. This goes more hand in hand, at least in what I was writing, on the economy of making. So there's this huge market right now, as most of you know, like West Elm is partnering with local manufacturing. And you see that a lot in social media, and it engages a lot on the kind of market discussion on that. All the way to the future of homes, from WikiHouse, of whom I think most of you know, open plans, to more classical examples like Elemental, where Alejandro really kind of tries to push for that agenda. And then the question from there is the pushback of, if you open source your blueprints, who is actually going to be the user of these blueprints, right? There's that kind of double-edged sort of discussion through digital networks that are trying to open up discussions on commons, mapping, networks, all the way to what Ben is doing with the UN Studio, kind of on an AEC side, planning and processing and tooling. There's a huge critique that I have in my dissertation on this and whether or not it's actually working for privatized companies, such as a big studio like UN Studio trying to push this out, mostly on white papers, all the way to how kind of GT became a premise of selling the business, which is quite recent, to Tremble, and it kind of went air dead after the sale. But that's a whole different discussion that we could probably go into. And then to the kind of more front-end corporate discussion of distribution of robotics and the future of work, where Tesla and other companies like Alphabet and everyone else is actually doing way better at than we are doing in our industry. So the kind of, I would say the filth realm of looking at technologies and manufacturing goes also hand in hand in terms of how industries outside of architecture is actually engaging in the realm of manufacturing. So this chart actually, Kevin, you have had touched this chart on the diagram, and a lot of the current work of construction right now that I'm looking into with robotics and or automation is kind of seeing what the dollar bill discussion is. How are we pushing the future of construction and AEC beyond just the cusp of what the research and ethics are doing, but how could we build into the construction industry a better understanding of computation within it. So, do I have like another 3 minutes or so? Right, I'm gonna speed on. Basically, and then there's like a whole chapter I'm writing on like citizenship and governance. This is Obama's policy. Don't know what Trump's current discussion is on this, but this was something I thought was like, wow, you know, the government is actually really opening this up. A lot of the inspiration was on the actually second Obama speech on like how he actually had a huge 3 paragraphs on 3D printing, and it has this like, you know, the future of how we're Americans, not we, I'm not technically not American, like going forward with policy into how we govern open governance. Back to what we're looking at. So these are some projects that we are also playing with. These are just, because I'm totally skimming through this. Sky Vodka was a project that we recently worked on. Wonderful clients, all the way to kind of like smaller projects for Asia Society that we also engage in play and like in interaction and kind of proposals that we went through that also are both digital and making, and these are some projects for MOOCA Shanghai, and we worked with some students in actually making it. The whole project was only under $5,000 US, and we got it done in 2 weeks. And this project was also a partnership with Daisian, and kind of like really hands-on, just playful. And then to the current stage of what the new school is really trying to foster in terms of making and looking at the network of New York. We're really trying to focus a lot on how the space itself could be a fabrication tool for inside the school, but also opening up larger discussions on how to partner with the city. And I think the core to that subject is also bringing in discussions like ADO down at Greenpoint, New Lab in Brooklyn, Navy Yards, Sunset Park, also deep in Brooklyn, where a lot of startup communities are building up, from Google to Alphabet in general, to a lot of robotics labs are also relocating there. And also to what we're trying to do at New School, and maybe we could feature that discussion with Columbia, and kind of the next steps on that. That's fine, I won't play this video. I'm gonna do a plug, and this is like a book that recently came out with AD. I wrote it with Professor Anton Picon at Harvard, and it is on the subject of what my research is, but also a lot of great names that contribute to the larger discussion of what digital property is and how we kind of see what open source architecture could potentially be. And so that is me in 15 minutes.
So Ariel is an architect, fabricator in Brooklyn. She also has a multidisciplinary background: fabrication, architecture, graphics, identity, passionate about making things, kind of the same kind of guiding principles we find here. Ariel and I actually came through separate architecture institutions at kind of the same time, and I kept hearing her name in different contexts, like this time as an expert activist, and this time as an expert graphic designer, and as an expert crafts person. So she's kind of been there. Along the way, she's helped lead the curatorial team for the U.S. Pavilion, the Venice Biennale. She's left one of her models in the permanent collection at MoMA, the Snow-Headed Opera House that I think all of us have pinned once or twice. And now Ariel runs Slash Projects. It's another multidisciplinary that includes Slash Objects. I'll let her talk about it. I also want to mention that I have an oblique but wonderful connection to Ariel through her advocacy work at GSD for Women in Design, an organization that she started with this kind of name as mission statement. So Ariel was behind the organization to help get recognition for Denise Scott Brown and the Pritzker a couple years ago, which was a pretty incredible effort at the time, and also like a necessary and prescient thing for the conversation that's still going on right now. But through her work, and people I'm close to in Philadelphia, where Denise lives, I got to know Denise and Bob and know about Ariel from a distance, and so we know each other more now. So thank you for that, and thank you for coming here today.
Yeah, thank you. like Josh mentioned, I have basically a multidisciplinary firm called Slash Projects, and I'm going to talk today more about the line of furniture and products that we developed called Slash Objects. And I like to think about it that we kind of make digital and physical products and experiences. So situating the objects within the context of materiality, I really think about it as the line being unified by the use of appropriated materials to create interesting and innovative juxtapositions, and really kind of playing with materiality to understand how design can impact the way we use materials. And for the sake of this talk, I think it's super poignant to point out that, yeah, Brooklyn is absolutely a hub of making culture. Our office is in Greenpoint, and pretty much all of the fabricators that we work with are within about a 10-minute radius from die cutting in Williamsburg. A company that has existed for the last 100 years still makes rubber gaskets and also cuts rubber for us. And then from the different metal fabricators and metal finishing services, metal spinning, there are a lot of different techniques for metal finishing that you learn when you start doing metal work. And then all of the marble yards that are also conveniently located 10 minutes away from the studio. So the work ends up kind of bridging multiple materials, and it's really made possible because of the proximity of all of these fabricators and just the resources that exist still over time in New York at large. So the original kind of project of Slash Objects was taking an industrial rubber product made of post-consumer recycled rubber particles, and I like to think about it as a kind of domestication of that rubber. So it existed in certain contexts before, and how do you bring it into the home? And so one of the first pieces was basically these kind of side tables that are, the exterior looks like a terrazzo, but it's really made of rubber particles that are old tires, old playgrounds, old shoe soles, and then reappropriating it and casting it together with concrete and brass. And really thinking about, how can this high endurance material transform into something that people find elegant and something that they would want to live with. And a lot of people always ask me, how did you start working with this material? And as a young architect, I was kind of working on some high-end residential project in Soho, and it was my task to spec the gym floor. It was going to be a chic gym in the basement of this Soho building, and so I found myself with a ton of gym floor samples. And they sat on my desk for months, and I just kind of thought, this material is really cool, and nobody does anything with it that's not high endurance flooring. So, that was really the beginning of it, and I started researching it more, understanding all of its properties. It's heat resistant, it's obviously super durable because it's made for high endurance. And so it really began with a very loose set of experiments, what would happen when you bring multiple materials together, and understanding what its adhesive properties are, what its ability to bind with concrete is, and then essentially developing a technique to offset weight when combining these materials, and finding ways to bring the different materials together, really. So one of my favorite moments was kind of the first time a flatbed truck arrived with just like 2 sonotubes in Greenpoint, where there's a ton of construction going on, and there are flatbed trucks going back and forth with tons of building material, but they kind of arrived at our studio with these 2 little tubes tied down, and that was kind of the beginning of how we developed the technique to essentially hollow cast and simultaneously kind of fuse the rubber with the brass in the rubber side tables. So this is the range of colors that we developed as a starting point from the hundreds of colors that exist. And And then taking that idea into kind of a more conceptual phase, we were commissioned by an initiative called Design for Progress to donate a piece to raise money for efforts to kind of combat all of the Trump issues that we are facing. So the idea was to think about bringing together two types of rubber and this notion of duality and fusing of materials and really playing with the texture of, you know, the pure black neoprene and the recycled rubber tire material, and how do they come together. And then also bringing in this idea of what is the state of the union and that duality that exists. So it's really largely about, you know, using design through materiality to also convey some meaning and then at the same time, we developed a smaller range of products. A mirror that uses the rubber as an accent. So I like to think of it as kind of like the rubber is both functional, because it's protecting the surface, and it's also visual delight. And then a wider range of kind of tablewares that achieve a sort of full domesticity of the rubber. You know, people eating off of this, what used to be a gym floor material. And then through that process of experimenting with the concrete and the cast pieces, started to kind of broaden the range of materials. And I think part of the kind of recontextualizing of the rubber is also about bringing in another material palette. So we started working with marble at a larger scale, which this was kind of one of the first marble pieces. But that brings me into the next kind of collection, which was called Coexist. And again, thinking about the way materials come together is pretty much central to the whole project. And also kind of really thinking about the state of the union. So the kind of early concepts were about, you know, this a pyrite, which is a natural formation that exists. It creates these perfect cubes found in nature, and it's also called fool's gold. So I was kind of playing with this idea of Trump being elected and this natural formation. How could that become a furniture collection? So the three pieces that came out of that were really about bringing marble and brass and certain types of rubber as well into the collection. And all the pieces don't use any hardware, so they all kind of fit together as puzzle pieces. It's kind of relying on one another in order to coexist. Again, thinking about kind of like the general state of our country, and so using marble yards in Greenpoint and metal fabricators also very nearby in order to really get those two parts to fit seamlessly together. Really couldn't be done without that proximity. And starting with a very kind of loose model-based process in our studio to kind of create these final pieces. So this is the Coexist coffee table, marble slab, a cube turned on its knife edge that locks the marble slab into place. And those are the only two parts that exist in that piece. And then also thinking about material use, there are a lot of remnants that exist in the fabrication of marble, you know, countertops, etc. So how do you transform those into beautiful, functional pieces? So the creation of the Coexist mirror and a Coexist askew side table, and again, just three parts locking together for the mirror, and for the side table, just two parts that slide into one another and basically counterbalance in order to function. And then finally, I'll talk about the Norway Light, which was a project I was invited to collaborate with a designer based in Norway to create a piece for Design Week last May. And we were really interested in creating a piece that could stand alone, that was somewhat kinetic, and that was kind of inspired by this material palette, and this idea of a shell, the idea of a pivoting brass disc, the idea of light being shifted from one place to another, and through a process of experimentation, it really became about embedding a lot of the lighting hardware into the thinness of the concrete shell, and then understanding how all these parts again could fuse together in a really kind of thin and unified way. So this is the final product, which we're developing now into a broader range. So the brass disc pivots in order to relocate the light, and everything is basically embedded into the shell itself. And so really overall, I think the project has been about exploring how materials can be used and decontextualized, and then kind of brought back around into a new way of existing. So that's basically
our home team member, Ryan Johns. He teaches a robotics class that people probably know about here called Assembling All Sorts. So he teaches robotics and looks at digital fabrication, sensing, interaction at really fundamental levels. His practice does similar things. And he's not only our resident robot expert, or robotics expert, but I would call part of the spiritual core of attitudes towards machines that we're trying to sort of develop here. We talk a lot about the shop, the machines in the shop, the purpose of the shop. It's kind of that attitude where technologies and techniques are looked at in a creative and comprehensive way, where every part, program, and order is on the table for reassembly and reappropriation. So, I mean, I would call it hacking, but I don't think it does it justice to the sort of constructive nature of it, and making new things out of things. So anyway, he's been a big part of the conversation and the mission statement of the Fab Lab. So, Ryan, thank you.
Okay, so as you can see by the kind of obvious title here, I'm from this place called GSAPP. I'll talk about it in a second. And I'm interested in fabrication, not necessarily, kind of more in the dual sense of the word. So as architects, of course, we're trained to make something out of nothing, which might be the first form of kind of fabricating something. But fabrication is also a word that means to kind of falsify and to create kind of unreal information. And that's kind of where I find it interesting, because when I was a student, I found that if I just kind of made a picture of something, or I just told someone, like, what if we had a drone that could make a wall in a desert or something, someone might say, yeah, that's kind of cool, but it's a stupid and unrealistic idea. But if you all of a sudden make a demo of something that you can show someone and they believe it, or you make a physical object that they can touch, your kind of fantasies that are entirely unrealistic become kind of true, and someone will give you feedback and understand it. So I think when you're making things, it's not just about realizing your design, but it's about realizing a seed of something that then you can kind of prove to someone the kind of authenticity or the kind of potential of what you're doing, and to kind of think about making as a form of kind of creating just the level of truth that's necessary to kind of convince someone to kind of lead forward. So GSAPP started when I was a student at Princeton, in this kind of like maybe theme of garage startups. We literally just bought an industrial robot off of eBay for $10,000 of student loan money, cast a concrete floor in a one-car garage in Princeton, built a phase converter, and started doing research while I was a student there. We've since moved, in a kind of battle of square footage that I think everyone has been going into today, to a 21,000 square foot space up in Poughkeepsie, which, if I had an awesome fly-through video, would kind of look like a horror movie combined with a kind of mad research lab with robots with chainsaws and lots of big holes in the floor. So kind of thinking about how we think about design, I think it's important with these half-truths that us as architects really make people think about, why do we make things? How will we make things in the future? What's the purpose of kind of labor? How can we create more moralistic practices of architecture? This is Villemard's view. It's a really common image of the architect in the year 2000. A lot of kind of fabricator people like showing this But I show it for the opposite reason. And one, it's cool because it's like this architect, he's just, all he has to do is press a button and he's got this plan and these really cool looking machines are building this thing and, you know, doing everything. There's no kind of laborers anymore. And to me, it's a super depressing George Jetson view where you go in and you press the one button in the morning. It's like, what's the role of human in this kind of future that we're making? And I think that this fear comes a lot, it's a kind of resonance of the kind of original first industrial revolution Luddite fear of machines taking our jobs and going out with sledgehammers and breaking all these machines. And you'll see every auto company in the world is showing these images now, you know, humans working along robots and pumping collaborative robots like they're not taking our jobs and instead you're just sitting there and kind of watching it do nothing and occasionally putting your hands around it. And it's like, how can we think about how this might be for us as architects? Because, you know, we have these kind of things that we do, and machines do things really well, and computers actually design things really well. So what's our role? So this was one test I did. I kind of took all the videos out of the slide. You can see them on the website if you want. Where I'm wearing an EEG headset, and the robot is just, you know, kind of manufacturing the Nike logo over and over again. And depending on my focus levels, it draws this drawing kind of more and more like a 5-year-old. So it's like the architect, you know, is there just as a kind of thought machine, and just to know that your object has human thought behind it is the thing that kind of gives this thing error. Another kind of similar project that we did was this sweater, where the quality of the sweater is based on data as recorded from a Fitbit. So you wear one of these kind of ridiculous exercise tracking watches, and your day gets turned into the sweater, where moments of high activity become kind of perfect, colorful, tight-knit, and moments of low activity become, you know, holes and kind of loose, colorless fitting areas. So some of this narrative kind of comes a little bit from this question of, you know, how white-collar labor has changed our practices today. So kind of going through a test narrative. You know, this is Alan. He's a guy that kind of is modeled somewhat after my brother. You know, Alan is shopping on Etsy. Handmade things are just nicer, and human labor adds value. Which, you know, if you look at the technology of digital fabrication, we're seeing a subsequent rise in Google searches for the word handmade, because people will actually, you know, the effort heuristic encourages people to prescribe for two exactly identical objects a higher value to the one that they think a person had labor inserted into. So how can we embed labor into these kinds of objects? So Alan works on a computer most of the time. Sometimes he's nostalgic for the physical labor that he's never had to do. His grandfather was a mason, and his father was a mechanic. Robots do those things now. After work, Alan goes to CrossFit, where he moves blocks and tires around. Sometimes it feels weird to not actually be building anything, so like he's doing his job, and then gives him the money to get the gym membership. Going out at night, Alan prefers distressed denim, rugged worker as he sexy looks. He's kind of paying also for this appearance of being a kind of laborer. And he wears an activity tracking watch that measures how much he walks and exercises each day. He's running a marathon for charity. The more he runs, the more his friends donate to the homeless. It feels nice to be doing good, and running is much more fun than actually working in a soup kitchen. So this is one of these questions of indirect labor that I have. Like, why is it necessary for you to donate money to cancer for some random person to run a marathon? There's no correlation between the kind of moral output of your money to a good cause and like someone that you knew exercising for their own benefit. So, you know, the sweater is just kind of another one of these things that we have. So, you know, the more he does in a day, the kind of the different qualities of sweater have. So you get kind of tighter knit or loose knit. And of course, Alan is proud of all the very hard physical effort that went into making this sweater that was designed and produced by machines that is kind of based on his own sweat equity. So kind of thinking, you know, this is maybe more of a dystopian view of how we might go forward. I had the pleasure of working briefly at Komatsu Polar in 2011, where I was working in this kind of interactive robotics, you know, many ideas that are kind of correlated and linked and related often to Wendy's work as well. Here, you know, kind of drawing the line in front of the robot and having it immediately build a brick wall along that path. So the idea that maybe our role as humans is actually bringing some form of gesture and kind of human intelligence onto sites as they're going. And then working a little bit with kind of information feedback, so AR headsets to kind of allow us to, this was a really cheap you know, Vive or anything, way of just using an Android phone and a Kinect to track where my head was and allow me to kind of draw and see these things in real space. And through kind of verbal cues, create these various locked surfaces. that could then be kind of spoken out to kind of be produced into G-code or laser cut files for producing objects based on gesture. And so with this project, a lot of the question is about how, if we want to do interesting things with machines, and we want to work with machines, and we want to be involved as people, one thing that we really need is an interface. We need to be able to interact with these things, but we also need to understand them. And our phones do a pretty good job of this, of just kind of telling us where we need to go and helping us interact with the world and also not. But fabrication machines kind of right now do a terrible job of this. So 3D printers you can kind of guess a little bit how far your print file is because it's like a loading bar where the taller it is, the closer you are to done, but that's not necessarily true. But a CNC mill is kind of often optimizing a path that's non-linear or non-rasterized. So how can you actually tell what it's doing? How can you change it halfway through? So a lot of my early work was focusing on creating these kind of augmented reality interfaces that show you the tool path of the machine as it's going, but in doing so also allow you to modify that as it's going to say, if I want to focus on this area because my crit's about to happen, how can I make an interface that allows me to kind of zoom in, mill that area really quickly, and then go back to doing the rest of the process. And the nice thing about creating interfaces is they also make it so that you don't even need machines sometimes. So this was a project that I did in collaboration with some past classmates of mine recently for Performa, where we basically had a kind of a card game, and the results of each card game kind of turned into this pattern on the wall. And the pattern was kind of controlled by chance based on the way that the kind of labor and the playing went into the games. But there was a projection map environment that, based on the results of every game, told people where to tape their cards. So these kind of blue and yellow squares would pop up depending on what table you were on, and you would tape your cards. So you ended up with this kind of very precise parametric pattern, but without actually needing any kind of robotics or anything to make it work. So in kind of looking at this, a lot of my work is thinking about, how can we optimize these two middle things to kind of make them disappear? How can we make machines that allow us to interact more closely and kind of get our hands on materials and really put our labor into those things? And part of that is with my interest in materials. So this was a project that we did in 2012, basically by kind of experimenting with combining a bunch of liquids and thinking about neutral buoyancy, creating kind of resin mixtures that allowed us to kind of create very fast, unsupported 3D print materials that we could kind of print very quickly and then pull out of the bath. Speaking of copyright, you might have seen this project coming out of MIT like a year ago also. Same material, same process, but way flashier videos. So kind of working to combine all of these things, we came up with this project. This is my first foray into what I call augmented materiality, which is this process of allowing kind of interfaces to allow us to work with complex stochastic materials that we wouldn't otherwise be able to handle without kind of interface design. So this is a robot that has a scanner and a heat gun mounted to it, and it's iteratively melting and scanning this block of wax. You put a load block on it that represents where the structure needs to go, and the system calculates using topological optimization where the structure is flowing, and the robot goes to kind of proceed through and iteratively melt away all of the materials that aren't performing. And the nice thing with that is that because it's not like a G-code process where you send a file and it just does it, it only looks and melts and looks and melts every single step of the way, so that you can at any time go and modify this path by coloring on the surface to say, I don't want material here, and it will kind of thin and change the model to match your desire. So this process allows us to kind of create a balance between our design intention, the properties of the material, the kind of structural demands, the kind of performance requirements, and the kind of agility of these digital fabrication tools. And you end up with this kind of super grotesque thing, which is kind of, I guess, my aesthetic for the most part, of this kind of melty wax that's like neither here nor there. It's neither precise nor imprecise, but to me that's kind of where things are at, and I think of that a little bit in terms of the grotesque is also relating to the grotto. So the grotto is this place that's kind of hideous, but it performs. What's interesting about it is that a cave that was made by nature also meets the demands for our occupancy. So how can we, as architects, instead of fighting nature, begin to use it to make these things that are hybrids between what materials and natural elements want to do and what we want them to do. So some of those kind of similar processes are, this was from the Seoul Biennial. basically using irregular found materials. This was an exhibit where people could just drop things out of their pocket on a conveyor belt, and the robot would build a kind of a wall, a dry stacked wall by scanning those and fitting them together. Of course, that's really closely related to the teaching that I've been doing here. Assembling all sorts is focused on basically creating fabrication processes where you choose a kind of a readily available material subset and program robots to recognize and build with those irregular materials. And the reason for this is kind of this disdain of mine for the way that architects make things now. It's a kind of very linear fabrication process. I talked briefly in my class about this project by Atmos Studio. It was a great practice, but they were their idea was to make a tree. And so what does an architect do when they make a tree? They rhino model a tree. They kill like 10,000 trees and turn them into plywood. They contour cut their model into a bunch of pieces. They buy like thousands of dollars worth of hardware. They bolt all those things together, and then they sell their client this tree for X dollars. When someone else maybe in the country might say, well, I've got a tree in the backyard, just give it to you. And this is how things kind of used to be done before the Industrial Revolution. We would look and kind of fit things into tree sections to get the kind of most strong material, and you would kind of even chain trees and kind of encourage them to be what you wanted them to be. But in architecture now, we're dealing with this massive waste because we're so inefficient, and we push all of our design freedom to the design stage. And if we could just push a little bit more of that to the kind of site of fabrication with our design, so we could be adaptive and begin to kind of use material much more efficiently. So there's actually a lot of other industries that do this quite well. So, the meat industry, obviously, you never ever wanted a cubed piece of meat. You just get a pork leg and they just hack it off, and if the pig's a little bit bigger, a little bit smaller, it's not like there's a 4x8 sheet for beef. Maybe you get a 1 pound or a 0.7 pound or whatever. And so I started a couple years ago watching these, kind of getting sucked into watching robotic meat factory videos. So this is like fully automated robotic meat factories where they'll x-ray scan something, figure out where all the cuts need to get made, drop off a leg, throw it on a packaging system, and you get this super efficient process that almost no humans are involved in. And so we started applying some of those thoughts to woodworking. So basically, we came up with this algorithm where basically for any given 2D irregular curved flitch, you can essentially, by cutting with a robot, you can basically cut a bunch of slits that allow you to, with zero waste, transform that geometry into something that's doubly curved and kind of occupiable as an architectural thing. So the robot here provides us the benefit of being able to cut a piece of wood without any jigging required. And this algorithm, basically, I won't go into it very much, but it kind of allows you to design within a kind of selective subspace, but a kind of a large kind of domain where you essentially design your goal surface and then notch it and re-nest it and then optimize it so it nests back into this kind of finished surface. And what you get, this is one step from that 3D scanned piece of wood, where all of these pieces begin to again stack up and dowel together into this one finished piece that has essentially zero waste and a really strong, I'm not going to go into the waste story, there's some sustainability stuff, whatever. But basically, that edge over there is bark, this edge under here is bark, and you can actually see this kind of piece of wood splayed out very efficiently. And stuff like that. So I'll end on one last project, kind of flying through tons of stuff, in that this project actually led me back to getting a grant with the Australian Meat Processor Corporation. I've been kind of doing some research with them over the past few years. This is our lab in Poughkeepsie, just kind of 90 minutes north of here. And this is actually an unedited photograph of an environment that we set up that has a calibrated projector, 3D scanner, sensors. There's a bunch of sensors in the saw that get projected as graphs onto the wall so that you can know at all times how much resistance is going under the blade so that you can optimize the cut speed based on the path. The robot has all this information projected onto it as to what it's doing at all times, so that if you're walking by to collaborate with it, you can know, it's about to make a cut, but it's doing this thing upside down, I should hit the emergency stop. And how can this kind of providing very obvious visual cues allow us to actually work with these incredibly complex machines? This is a similar process, basically calibrating a thermal camera with a projector, with a 3D scanner, so that for any 3D point, you can get the temperature of that point and then project that temperature back onto objects in real time. So that as a human walking through a space, you can see where temperatures are on objects without actually needing to touch them. And this is very important in an environment where temperature is really critical to the kind of value and safety of the things that you're making. We do a lot of metal fabrication as well, so this was a kind of custom pneumatic gripper that we made that kind of adapts to the things that it's picking up. Also making these custom adaptive grippers that kind of flex and form to kind of pieces based on Festus fin grippers and other similar things. And then also working a little bit with manual processes. So the thing that I really try to do is push the human back into that. So using this interface, we set up an automated motorized blade guard and gauge plate so that as a human, when you put this thing down on the table, it automatically drives all the safety mechanisms to the right place. To where we were noticing in factories that people never took the time to adjust the safety stops on their tool and they were just cutting these very unsafe ways. But this idea is basically to make a tool that intelligently always optimizes the height of its mechanisms to kind of prevent any exposed blade for your hands. That's kind of it. I'm going to end with one kind of weird image just to go back to the idea of kind of falsifications. I've shown you some kind of real things, but kind of ending on something else. This is a kind of machine learning based project looking at, not my own, basically looking at kind of neural stimulation read through kind of an EEG type headset. And the fact that you can actually, through machine learning and looking at what people are looking at, you can actually train it to look at only the brain waves that people are producing to recognize what the number is that they're seeing with their eyes. So we're now at a point where we can actually understand visual stimuli in people's brains. And looking at this project, this is from University of Pittsburgh Motor Lab, using a kind of related technology to kind of cause a monkey to think about grabbing an orange and actually having its thoughts drive a robotic arm that then goes and grabs that orange, and it gets the kind of treat of being able to taste orange every time it does that. But here, kind of more dystopian project at the University of Washington, they actually take a similar process. I'm sure you've all heard of Galvani, who made that kind of famous experiment of learning that you could electrocute a frog's legs and it would jump. Well, there's a kind of, we've gotten a little bit better at that. It's called functional electrical stimulation. You can actually shock nerve endings to make an arm move in a predictive way. So here they actually numb the nerve connections or kind of sever them between the monkey's brain and its arm. They register its thoughts, they process it through a computer, and then they use them to drive its arm. So it thinks, I'm going to grab an orange, and it grabs an orange. But what's amazing is that between the thinking and the making, there's a machine that's processing its thoughts and feeding it back to its own hand. So a lot of this work that I've shown to me is about how can we do that for us? How can we do that for us as architects when we work with machines, when we work with fabrication tools? How can we make it such that there's a moment of kind of intelligence and engineering and kind of the brilliance of computers that can be built into the ways that we do things to allow us to kind of design in the moment of design with the kind of intelligence that now we have to send to engineers and contractors to kind of then feed back intelligence to us. Anyway, that's it.
Okay, finally, Madison Maxey. Lots of potential titles: technologist, inventor, designer, founder, director, fearless leader of Lumia. Lumia's research startup is best known for its work in developing proliferation technology and conversation around smart fabrics. That is, wearable things embedded with human interface, which we've kind of touched on from multiple perspectives today. But as if that thinking isn't big enough, Maddie's work touches on just about, I think, every fascinating intersection that we find here in school in digital fabrication, pure material research, integration of synthetic platforms with human life, futurism, of course, the body, fashion, and ultimately collaboration and entrepreneurship at the center of it. So very happy to welcome Maddie Maxey to GSAPP.
Hi everyone. Well, thanks for sticking around. I know you've been around for a while, so I'm looking forward to sharing with you. And my presentation is pretty brief, and it touches more so on some of the issues in the smart textiles and smart fabric space. You know, a little different from architecture and creative structures, but I wanted to share with you some of the issues that we're working on and why I think this space is interesting. So here we go. Also, our plan today is an introduction about Lumia and what we do to set some context, and then all about making e-textiles, electronic textiles. So I've worked in a few different spaces, a little bit of 3D printing, digital fabrication. My background is in fashion, but I've always been really interested in the process of making things and making things of all kinds, especially when it comes to raw materials like fabric. Sorry, my somebody on the biz dev team makes this presentation, so it always includes like timelines and animations. So kind of my process to getting here was I did a program called the Chill Fellowship. Basically gives you money to leave school. I started this company as a studio that was then called The Creator. I did a residency at Autodesk. I think a few people here have mentioned Autodesk is a great place to work on projects. And then did a few things in the business space that got me on the 30 under 30 list, and then we rebranded to Lumia and started focusing on product. So that's where we are now. So Lumia basically makes a soft, flexible circuitry layer that can execute different functions, similar to how any rigid circuit can execute different functions. And our layer, the materiality of it is meant to replicate a textile, so you can put it in soft goods. It basically goes between an outer layer, or electronic layer, and then an inner layer. So if there's a brand or somebody in the furniture space, for example, who wants to use this layer, it's not meant to affect the design of their product. Some of the industry challenges around e-textiles or flexible circuitry is that things that are flexible often aren't soft or drapable. So there's a bend radius issue. One of the interesting briefs that we got was for capacitive touch sensors for a steering wheel, largely because using a flex PCB, there's a bend radius limitation. So you can't fully bend that circuit board over the steering wheel under a leather piece. Therefore, you need something that's soft, drapable, and isn't going to crease, which is different than I think a lot of the flex boards out there. Other examples are there are a few companies that make ribbons that have 4 conductors that are linear. If you're actually making circuitry, you need to be able to create new geometries. Any circuit that's just 4 traces isn't going to do a lot for you. So they need to be patterned dynamically and creatively to serve different functions. And you also need to be able to get something that's going to drape, that can still work after you crease it, etc., to use in any sort of clothing or soft good. This is just kind of an example of one of our materials being dipped into a tray of water. So you can see that some of the issues that we also experience are washability. How do you make sure that something's watertight because naturally you're going to wash it? How do you make sure components stay on and don't get affected by its environment? So this is one of the many things that we look at when we're developing a product. And just to show some integrations, we put one of our heating flexible circuitry layers in the sole of this shoe and all the componentry in the heel. So this is a women's boot, there's more room in the heel for us to do things with. But we're working on getting the electronics smaller for a men's work boot, for example, maybe for elderly shoes. So you can have heating in the sole of your shoe in a comfortable way, either for industrial or commercial goods. And our layer allows you to easily put it into the sole of the shoe. So that's where it comes in. You can see thermal scan, our shoes is hotter. Another example is you can use this kind of circuitry for flexible surfaces. So this was a capacitive touch matrix that I made on a second residency at Autodesk. It's basically a grid of, it's a giant e-textile basically, and it allows you to track things with your mouse. And you can see that you can fold it up and put it in your back, for example. So these dots are on kind of user interfaces. Cool, so my goal was to run you through some different use cases because people ask, what would you possibly use this for? And different things that you can use it for. Also, what iLayer is and what we do, and now here's the fun section on making e-textiles. So just some core vocabulary is around passive and active materials, like softness, which I talked about earlier, e-textiles and digital fabrications. For passive versus active materials, I think that it's great to create a clear definition between what materials that we often interact with do already and what electronically enhanced materials can do. So for example, if you have any sort of running jacket with 3M lighting on it, 3M reflective tape on it, does anybody have one of those? It's like, Jacob has one. And a few others, I think. Awesome. So those have a bunch of glass or plastic beads inside that when you hit them with light, it will reflect that light back at an angle that makes it look like it's glowing. For certain safety environments, you actually need something that can produce its own light, rather than just take light that it's getting and then reflect the light back to your eye. So a passive material is something that would take light from another source, reflect it back to you, and an active material is something that can generate its own light. And that's usually from a battery, but can produce its light regardless of what kind of sources are around. So that's kind of the difference between, let's say, a unique low heated jacket, which insulates you, and an active heating jacket, which takes heat from a battery and then brings that to your body in a comfortable way. This idea of softness, which I touched on a little bit earlier, is the main material challenge in this space. Mostly because you bring in these kind of floppy material problems. So if you've ever seen a robot try and handle a floppy material, it's really challenging because they're very unpredictable in a lot of ways. They stretch on the bias, they drape in all these funny ways, it's hard to grasp. You can't really do things on any part of the surface that you're not gripping because that part flops. So when it comes to softness and circuitry, softness is kind of that combination of floppy materials and drapeable, like extremely low bed radius materials. So a lot of what we're trying to solve is how to make these floppy soft circuits. But with that, you experience the hard-soft barrier. So any functional existing electronic component is going to be a hard component, and it's going to want to separate from the soft part of the circuit. So it sounds like kind of a silly problem, but it's something that people talk about frequently in the space, because that part where, let's say, you're mounting an LED or mounting a sensor is always going to want to move off of the floppy part. It's going to be hard to mount. So how do you get them to be well together? And in terms of electronic textiles, as a general space, it's specifically electronic, or specifically textiles that conduct data and current or voltage. And so this is what we're trying to get the textiles to do, and the space is called e-textile. So it's this softness, active materials that can conduct data and current or voltage. For electronic textiles, they tend to be particularly good for large surface area needs, as mentioned, drapeable, for low z-axis height needs, and they're very good for low bend radius needs. Standard electronics are very good for small surface area and very compressed needs. They tend to be more rigid, less low z-axis heights, a little taller, and especially for polyamide, they tend to have a higher bend radius. Basically, the purpose of this is to say that you wouldn't just use electronic textiles or standard electronics for these textile applications. You normally use them together because sometimes you need a bunch of components in a small surface area, which might be a rigid board, and then you need to conduct that to other places around the body, which could be your textile board. So fabrication methods in this space, basically at the end of the day, circuitry is pattern conductivity. And textiles have a lot of patterning techniques, which is great. We saw earlier some stole knitting machines. There's different weaving machines, digital printing machines, knitting, or I mentioned knitting, but hand knitting and different things. So when we think about digital fabrications in apparel and how they can tie to textiles, there's lots of good references to turn to. And looking at what people are doing in the space, a lot of people are using fiber and yarn-based digital fabrication methods that can be knitting something together, weaving it together, putting a conductive thread through something to get the functional circuit that they're looking for. So when you're designing a circuit that's using one of these apparel-based manufacturing methods, it's important to remember that the garment will always impact the circuit, which will impact the garment and vice versa. So the size and shape of your board is no longer, whatever size your components are. The size and shape of your board is whatever size the garment is, and wherever an easy place for a person to interact with these things is. So it kind of changes that design paradigm a little bit. And this was like an LED matrix dress that we worked on at one point. But the goal is to show you how the digital file was made to work on this dress. Mostly because, as you can see, it's in Illustrator. There's not any sort of software program that's necessarily meant for this. So you tend to hop between programs that don't turn into any sort of digital fabrications process. For example, with normal electronics, you might use Eagle, which you can send to somebody to the manufacturer board. But using Illustrator, you end up overlaying different files and then turning that into something that looks more like a formal circuit, like this, and these are all individual component files. And then turning, so this is an eagle file for an individual LED. And then turning that into something that you might be able to do with a standards apparel or textile fabrication technique. So using a conductive thread like this one, we can turn it into, I'm going through this quickly to get to this test sample. So from that large grid that I showed you, this is a snapshot of it that we then translated into knitting software in order to try and knit out the circuit that was designed in Illustrator and to see how that translates. So with that, it ended up translating into a piece where it was kind of hard to put any electronics in, mostly because you have continuous traces. So to embed the electronics, we needed to cut at every intersection, which gets away from this digital fabrications and kind of gets more into a manual process. So, at the end of the day, the circuit did work. We could program this LED to do different functions, which means that we're getting good continuity or good connection, but it's still not a quick, manufacturable, repeatable process. So at the end of the day, we're really working on trying to find these reliable methods of making e-textiles and have explored lots of different things like knitting, which was the example that I showed you. But there's still a lot of work to be done in the space. And if any of you are interested in learning more about this space, different schools have programs for people working on these kinds of problems. ITP has a lot of people in e-textiles, North Carolina State University, Carnegie Mellon, MIT Textiles Group, Drexel, and Cornell Textiles Program all have people in or around the space around functional materials. So I believe that's it for my presentation. Thank you guys for your time.
Maybe I'll start it off. Maddie, one of the things that you said that I think is going to ring the most poignantly to people in the room is that you were offered an opportunity and you left school. So that sort of step was the instigation for the sort of chain of events that we saw. I wonder what your thoughts are on what the space for sort of striking out in a direction of your own that you've gone could be at an institution or at a school. Like what would a school of art or architecture or industrial design provide for sort of like a new type of economy and new innovative space like this?
That's a great question. It's an interesting thing to think about too. We'll go back at some point. I guess I think the main reason why I wanted to try and do things on my own was partially the program that it was in, and partially because I think in some academic environments, probably not this one, you get spoon-fed a lot of the process, and I really wanted to build the skills around finding my own process, figuring things out. I was looking at a lot of internships that could conflict with classes, and the main push was to ignore the internships, follow the class, and I thought real-world experience was very important. So to take the internship, that was a good motive, and then I got the scholarship that made it particularly easy to continue on my own. But yeah, I guess in terms of a paradigm, I think that making environments around experiential learning and project management and development individually is something that gives people a lot of room to develop. What do you think?
Well, that's sort of I think the active question that we're talking about right now, and I think it's come up multiple times in people's presentations of what we do here and how it relates either directly or indirectly to what we do after school. So maybe I'd throw the question also to everybody else and sort of reframe it as, what's your project in school, or what was the sort of the line that you can draw between your aspirations and innovations in the educational system alongside what you're doing now?
I think it's really just trying to sort of keep the lines of inquiry going in the most continuous way possible. Following up on a lecture that someone gave when you were in school that you were especially inspired by, and actively sort of seeking them out and sort of pulling together the resources, the collaborators, the tools, the equipment to then take the questions and conversations in an academic arena to the professional world. There are so many different ways to do that, so many different models. Just the five of us out here, you know, I think are a good sort of cross-section of that. But, you know, to really like grab onto those things that you burn for, and there are ways to get funding either through grants or fellowships or, you know, through setting up a business or whatever, you know, just maintain that optimism that we all have when we're in school, you know, and the professional world will be receptive if you're very clear about what the questions are.
Yeah, I mean, I did to exactly the same point. I think I mentioned in my presentation that in this very room, I saw Gramatsu and Kohler drove the station on their robotics when I was an undergrad, and it was very impactful for me. And when I was on a crazy running trip, I went and visited them, and I worked there for a while. You know, and then when I was in grad school, you know, Princeton didn't have a robot, and it was like one of those things I was really obsessed with, and I was kind of disappointed. They didn't have one, but they kind of said that maybe they would get one. But then it became clear to me that it wouldn't happen in the time that I was a student. So when I came back from Graduate School, I was just like, maybe I can get one of these. And so I kind of figured it out, and that was actually what led me to getting a job, was like actually the lack of resources. Then I kind of installed the robot at Princeton, and like, well, you have one, so you're stupid. You know, and I think that for that thing, it's like you have to find a balance between kind of, I think, this question of continuity. So if the school gives you something, use it. And if they don't give you something, make it and figure it out for yourself, and make it so that when you graduate, you have those things. Because
Or ask for it.
yeah, or ask for it. I mean, I think that one thing that is true is that at school you have so many wonderful resources, and you have like all these people, and you have all these amazing tools, and you really just have to use them. Because, you know, I think half the time, you know, when I was in school, I would say a relatively independent student. I did most of the things in my own kind of home shop that I had cobbled together on Craigslist parts, just because we had weird shop hours, and I didn't like the bureaucracy. And we always joke that our practice is like a decision to change institutional red tape for duct tape. But I think that like GSAPP is a pretty duct tapey place. Like it, you know, I think there's a lot of access. I think that Josh, you're like pushing that forward, like that. Yeah, the access and the kind of openness. And I think that that's really important to kind of push and practice that. And I will say that one thing is like, I mean, I don't know how everyone else feels about this, but oftentimes I kind of wish that I could crawl back in and just like have free access without having to worry about paying a mortgage, without having to worry about like buying new tools, and just like being able to play around with toys. So while you're here, do as much of that as you can, because it's not free anymore after you graduate. I mean, you're paying for
it. So it's interesting hearing your story about Princeton, because I just don't remember any robots at all. And the only mechanical thing I had to play with was like the laser cutter.
Yeah, well, I put the robot in my
Right,
house,
yeah.
So
Yeah, like my experience there was literally go to the basement and then that's it. But yeah, I mean, the inspiration I think through school, I don't know, I think being scrappy is very important. Getting your hands dirty and really reaching out of your network is something that I really encourage my current students to do. At least one of the seminars I do teach is creative and entrepreneurship. And heavily we do look at partnering outside of the school. I'm not trying to do a plug for you guys at Autodesk, but I think that is really something that they really do encourage. At least if you're in Cambridge, you go to the new Boston lab that has all the robots that you can play with. And another one in Parsons, we're starting a textiles lab. We just got a Shinseki this summer. And it's probably one of the only 2 machines in New York City that's pretty actively run. We have 3 staff running it, 6 months spent in Japan. So this is I think this is something that's like as of a luxury in New York City, to have a lab that's actively located in Union Square and like 7,500 square feet of like active playtime. I don't know what the lab here is like anymore. I remember undergraduate here was pretty crap.
It's getting bigger.
It's getting bigger. This is a long time ago. So anyways, but like I just know that a lot of it is really about being scrappy, and New York City is such a huge network that you really could just be like, okay, I need some 3D printers. Even as an undergrad, I was like, at that time, I think it's Solid Doodle, they gave me all the printers. And then I kind of took some stuff apart and then got that going. And then recently, Bree is awesome. Bree Batiste, for you guys who know, like, kind of maybe a lot, right? So, like, he's currently considering getting rid of his clay machine, and like, we're talking, maybe there's a way to go upstate and use his machine. Like, he's kind of scrapped it right now. And then at our office right now, in Soho, right next to the new museum, because it's a dilapidated floor, Ultimaker is very generous in lending us their machine. So it's a lot of it, at least for us, and I probably am lucky, and I'm sure all of us are, we are able to kind of resource that material, and I think that is through partnerships, that's through like good communication of like what you're actually doing, whether it be an in-kind grant or through machine donation, and that hugely could help you on your research. And I think a lot of major companies like robotics, they don't explore the same type of research that architects or designers and or fashion designers definitely explore. So I think those are really good ways as researchers, as a student, as an academic, to really kind of push for. I know that Andre's not here anymore, but I created his position as a fabrication fellow at New Inc. So with the new museum and kind of be like, look, we need someone, and a program like this, so that we could have something to run the local museums lab. And how do we start negotiating that discussion? So it goes beyond just a discussion of internal, running a practice or running academic. I think the two partnerships are very important. At least that's how I see it.
Yeah, I mean, for me, I was kind of disconnected from school life. At GSD, I told myself, somebody had given me the advice, use the tools in the shop as much as you can, because you won't have them when you leave. So every semester, every studio project, I used a new tool, a new technology that I had never used. So I was like water jetting the first year, and CNCing, and 5-axis robot, just to push myself and also learn the technology and also kind of take advantage of all of the resources that existed. And 100% the desire to make /objects came out of a lack of those resources, because I was just like itching to make something physical again and not having access to an amazing shop and robots. So I was turned to Greenpoint, see who is around, what can I make in my community, and just speaking to one person leads to another person and another hidden weird shop behind an abandoned building, and you have sort of a network all of a sudden of these different fabricators that you can work with and who are excited about new opportunities and collaboration and love fun projects that are not necessarily just super like mundane day-to-day work. So I think there's a lot of opportunity to get involved with somebody who wants to work on an exciting project with you, because it is in the realm of design. But my number one kind of thing is to push yourself into using all of the machines, because you will not have access to them outside of the academic setting unless you get your own robot.
Yeah, I always tell myself and other people that everything is simultaneously very close and far away. I would second all the sentiments about using the shop so you have it. It's been in my life in one way or another every year, and now I live here, right? I also appreciate the sentiments about collaborations in the form of other people in the city, and even grants and fellowships. I think so much of the currency is what we see as opportunity in architecture school is our own sort of personal instigations and investigations, or competitions that potentially have cash prizes, but there's a whole sort of universe of opportunities out there that often involve money that you will not be sort of handed to you at school all the time, but with some personal initiative you can sort of find them and get yourself tied up in other things that are going on that can possibly pay you enough to do things. Would anybody else in the crowd have some questions?
Mostly for Ryan, but although all the presentations sort of touched on geography, and I saw a lot of maps of New York City, but Ryan especially went into, I think, some of like the relationship between rural places and urban places, and as someone who's sort of living this circulatory, or put together sort of a circulatory existence where you're coming back and forth and noticing these differences in attitudes and relationship to making things. How do you, did you notice that, and do you think there's sort of value in the countryside offering a city something and the city offering?
Yeah, absolutely. I mean, I grew up working on a kind of like in a rural farm setting, so I'm used to big things and kind of every neighbor having tractors and stuff that you can just lift up heavy things with. And now, like, you know, I mean, in Poughkeepsie it's nice. I can go across the street, there's a scrap yard. I asked the guy, hey, can I use your forklift? He'd come over and unload a robot or something for me. And it's just like a friendly nod. And I think that a lot of that neighborhood stuff exists in New York. I think the problem for me is that I kind of hate working for money. I mean, I have to do it. I do like this beef research. It's something I probably wouldn't do just like on a whim. But, you know, I think that for me, it's always been a struggle, like how can I balance my work effort with my desire to do this weird stuff that is like a thought experiment and kind of play with cool toys. And for me, doing that math, it was like, okay, some places in New York are like $30 a square foot a month. In Poughkeepsie, I can get, you know, at most expensive 50 cents a square foot a month. So it's like a huge drop. And, you know, like my partner, Gracia, lives in Brooklyn. I think everyone cool lives in Brooklyn, but like I went to undergrad here, and I'm kind of used to this area. And like it's like a 90-minute commute for me to like visit some of my friends in Brooklyn. I'm like, shit, it's 90 minutes to go to Poughkeepsie. And it's like there are trees that, you know, I can turn into projects and stuff.
For the record, I saw an hour and 54 minutes. So you were under Google Maps for Poughkeepsie.
No, that was commuting to the Navy Yard. Yeah, we were going, but I think it was from my apartment.
Yes.
Yeah. No, you know, so I mean, I think, you know, depending on the trains and transfers, you know, it can be quite problematic. But yeah, I mean, I think that there's not really a good solution. I think that it's really nice to be in the city. I know a lot of people in the Navy Yard. It's a super cool place. There's like all these people. I would say that, like, personally, I tend to appreciate being like a little bit of a weird hermit who just like doesn't talk to people and just like stays up late at night making electronic stuff. And I think that somehow like there's a nervousness of some kind of collaborations lead. Like I've heard so many sort of people in the Navy Yard being like, our neighbor, you know, did this project like, you know, a month after we did or before we did, but they had seen it happen. And it's like, there's so much of this kind of weird, and it's like a super good incest, but it's also like, I don't know if any incest is really good incest. I don't know if that answers your question. Come visit, it's nice. How do you like that?
Oh, that's good. Yeah, I love the community of the Navy Yard, and you know, there's that incest, but you can also just go for a walk along the river and, you know, climb down into a dry dock and be underneath the belly of a, you know, big barge, or, you know, you can have an experience that I think is every day up in Poughkeepsie or upstate, but you are within, you know, walking distance of the subway. I think we all need that kind of release from the city in different ways. So, I mean, I think there are ways to do it within Brooklyn, but, you know, I'm somewhat envious of, you know, the setup that you have. I grew up out in big rural landscapes, and I think there's a lot of potential between what we can do with better understanding nature and how, you know, systems work on a large scale outside of the city, and, you know, I think it's good to stay in touch with those big things that, you know, shape the world, and it's nice to, you know, find inspiration in nature and now to use what's possible in computation and computers and tools and whatnot to do things like, you know, cut a piece of wood to create a chaise, you know, in a smart way. So, I don't know, exciting times, definitely like that balance is the constant struggle, I think, for everyone.
I have a question about for everybody, I guess, kind of two-part. Your difference, or your relationship, or understanding, or thought on the difference between making and manufacturing, and then the relationship to industry on either of those sides.
I think that maybe one of the core differences between what I do, what the rest of the presenters showed is kind of this core difference between making and manufacturing in some ways, where I feel like making is really about the item, it's about the design, it's about solving a new problem each time and very creative. And I think manufacturing is a lot more of we solve the problem once, and now we have to figure out how to make lots and lots of them in a really big and reliable way, and market it and brand it, and that all comes into the industry side as well. I think that the difference, especially a lot of things that I've learned along the way, is that I think the difference is, it's kind of like just looking at what you want to build. I think building a certain skill set that allows you to make a lot of different things makes you very flexible, and I think it's a great education, and I think making something that's meant to scale and is meant to be manufactured forces you to focus on different things than necessarily just the skills to make a product, and I think that it's interesting to compare them. I don't know if that answered, but I hope so.
Yeah, I think very similar to what you said. I think there's the scale issue that brings in so many other implications to how you're using the materials and how the resources are allocated. And I think one thing that I've been facing, because my smaller products are now starting to look at making them at scale. So what does it mean to have 50,000 square feet of rubber and transporting it and die cutting it and branding each piece and making sure that there's quality control? It brings in so many other implications, and also how can we reduce any sort of excess material that comes from the cutting, and can that be recycled back in and done on the plant, and taking into consideration the weight of the materials, so that when you transport it, the cost of that is, and also the fuel cost of that is all kind of integrated into the product itself. So it really has this entirely other life cycle from its inception, which was making some kind of visually delightful, useful product, into something that can span many different circumstances and distances and use cases.
I think one of the core discussion that I actually have with academically speaking with students on making versus manufacturing is how much of it is core to the supply chain and how much of it is actually core to how many pieces you're producing. I think it's very difficult in the aspect of architecture or AEC to look at making in the scale of what fashion and or any design object, which these two wonderful ladies are actually thinking of. I think one example that, for example, this summer I was teaching Parsons Paris, we went to the Dior house. And yes, it's high-end luxury, but the core of what Dior's practice is also looking at the full supply chain of what it is to produce in terms of every runway for couture and every accessory production line for many, many bags on a high end, and scaled to how much materials actually work through use case. And then on the other spectrum of it is international distribution versus the kind of local, regional making. I think as architects, at least my architecture education, never thought of the whole business supply chain thought process of distribution. This is just very core of when I was here in undergrad. It was like I did architecture, but I also was focusing on economics. And I think having that economic background and that drive to have that entrepreneurial push to what you're actually thinking of will actually assist on your thought process of what it is to bring your product to an international sphere of thinking. And that is not core to the architecture education, of which this is a whole different pedagogic discussion that I constantly would love to have, is that making is, at least how I interpret it, is a very kind of localized discussion. Manufacturing is something that an engineer would be trained to do, and an industrial designer would. And a lot of times even, I would say, more on the fashion school, at least at Parsons too. And I think that discussion needs to be more closely in line in architecture education. But this is just me.
Yeah, I think it's a great question, and also really great answers to think about the question of supply chain and how that influences design. And I think that one of the things that I talk a lot with my students about is this idea of like design morphospaces. So like looking at what's possible to you in terms of not just what machines are capable of, but what materials are capable of, and kind of fitting your design into a realm of possibility that's achievable. And I think in some ways both makers and manufacturers are subject to kind of issues of material consequences of supply chain, but I tend to think of makers, personally I divide makers into like two categories. It's a really common word. There's like I would say non-techie nerd people think of maker as like, coverall wearing, like bearded hipsters who like make cheese, artisanally in like some old brick warehouse in Brooklyn. But then like I normally think of makers as like kind of like nerdy people who post things to Thingiverse and like print normally like hideous orange contraptions that like link things with rubber bands and pencils to like make things. And I think for me that is, I think I come from a history of like the second of like more of like a tinkerer. And I think almost tinkerer is a better word because makers. I think of the maker movement in terms of the kind of 3D printery maker as being kind of like a low craft fabricator. So it's like you want to make something that works, you want to make something with, in a way, your kind of localized supply chain. So you have a 3D printer, you can get rubber bands at Staples, you can get X and Y, and making something that can control the lights in your house or that can do remarkable things with these like really limited tool set, I think is actually an amazing design expertise. But I think that the one thing that architects have, which I tend to kind of differentiate architectural fabricators or quote unquote makers as being a little bit different, because one thing that we embed into that is like design. So like how can you make something that works but also something that looks good? And this is also the question of believability. So how do you, when you make something, how can you make something that's just enough that it kind of is a prototype that then you can sell to get funding or to get someone to loan you or give you a printer or to give you a grant or something. And then I think dealing with obviously the much more large scale issues of how do you get 10,000 of something made versus how do you get one of them made? Like I get bored after two, and I think that it's an incredible skill to have the ability to, my partner Nick, who we work on a lot of projects with, works for this company called Social Bicycles that's based in Brooklyn, and they're getting about 100,000 bicycles made this year. And to deal with that supply chain bump from like 10,000 bicycles last year is just a massive demand. Like the most minor inefficiency of some weld having an extra millimeter is gonna bump your costs up by thousands and thousands and thousands of dollars. So that's definitely where manufacturing becomes quite a bit different than anything that I get close to.
I would add, and maybe just to tie it together a little bit, and jumping off from Ariel's work, where there's such an intense amount of investment in research and craft that goes into making a product/prototype that then becomes the basis by which you could think of developing a line of product from that. And it goes back to what we do here, where we're sitting on a lot of technology that is dubbed as rapid prototyping when it's really anything but. You can hand throw a $90 handmade plate on Etsy and fire it and kill them twice in the time that you could 3D print something on half of machines like that, right? So there's a bit of that fabrication, conceptual fabrication, in the technologies with promise that we're reappropriating to put toward ends that are making models and prototypes at best. So that tension always exists in the shop, and I think it extends into the architecture projects of studio, even if you're designing a detail that's supposed to proliferate through a building, or if you're designing a sort of node that's supposed to proliferate conceptually through a project or a site. It's kind of the same question. So I would say that we try to answer that in the shop by making everything a little bit between the made and the manufactured, where we try to think of everything in two ways: as a one-off as a one-off exploration or experiment, and two, as a proof of concept that could in some sense get there when the technology gets there, or those 3D printers that are going to be 5 minutes finally appear. But it's always there.
And I think to that note of working with these processes that aren't necessarily efficient is actually where architecture has a lot of power that's being kind of misutilized. I think that when a lot of architects get out of school and they start practices, the question is always, how can I make this as cheaply as possible? Architects are always notorious for not paying people. That's partially because people don't pay architects as much as maybe they should get paid based on time commitments and stuff. But I think it's something that architects can do, because when you're in school, you're not dealing with the efficiency of, I need to make 10,000 plates. You make one, it's like, how can I conserve as much material as possible? How can I use as little unpaid intern labor as possible when I do this? How can I avoid manufacturing overseas when I make this? How can I, reduce my embodied energy when I make this? And these are all questions that if we start designing that way, when we're not subject to these kind of supply chain and manufacturing limitations that industry have, we might be able to actually push industry into a way that's much more sustainable, where we're doing kind of localized fabrication and stuff, all these kind of things that C2 is working with, and kind of using local industry and local marble shops. And that's, I think, something that most people who are, if you go to a giant company that's a manufacturing company, they're not really trying to solve these problems, they're just trying to reduce profit margins. And I think that makering is one way of doing it.
All right, on that aspirational note, thanks everybody for coming, and thank you.